And we're live. Hello, my name is Taylor Fausak. I'm a software developer here at OrgSync, and today we're continuing our Better Know a Language series with PureScript. To get started, just a high-level overview. This is what Lars asked a moment ago. What is PureScript? It is a small, strongly typed programming language that compiles to JavaScript. And they have a more thorough description on their actual package page, which says it's a small, strongly, and statically typed programming language with expressive types inspired by Haskell and compiling to JavaScript. But I feel like all that's a little bit wordy. What it really is Haskell for JavaScript. There are lots of Haskells for JavaScript. Why would you want PureScript instead of any of them? The ones that I know of are Emscripten, which isn't necessarily Haskell for JavaScript, but it's LLVM for JavaScript, and you can compile Haskell to LLVM and then take that and use Emscripten to turn it into JavaScript. There's also Fay, which is a language that is a strict subset of Haskell, and you can compile it to JavaScript. GHC.js aims to be exactly GHC, which is like the premier Haskell compiler. It is supposed to be that, except instead of compiling down to native code, it compiles to JavaScript. So it tries to support everything that Haskell does. There's also Haste, which is similar to GHC.js. I'm not entirely clear on how they differ nowadays. And UHC is a different Haskell compiler that can target bunches of different backends. One of them is JavaScript. There's also other languages that are inspired by Haskell that target JavaScript. Elm is one where its focus is on the front end and FRP. Also, JMacro is a thing that gets embedded inside a Haskell program and generates JavaScript code. And there's also Roy, which is a language that's similar to Haskell, but its compiler is written in JavaScript and it compiles to JavaScript. So given that there are these 8 other options for doing Haskell-like stuff in JavaScript, why would you want to do PureScript? And there's a couple reasons. One is that there's no runtime. So the problem with GHC.js and stuff like that try to take Haskell entirely and port it over to JavaScript is that you have to have a runtime because Haskell is a lazy language. So to make a language in JavaScript that behaves exactly like Haskell, you have to do a lot of work. So PureScript, since there's no runtime, it means it's strict, which means that it has the same semantics as JavaScript. Depending on how you feel about strictness versus laziness, this could be a good thing or a bad thing. But I think matching what your host language does is generally a good thing because the performance is going to behave very similarly to how you already expect. The foreign function interface in PureScript is also a lot easier to use than some of the other ones, particularly because it only targets JavaScript. That means that it's very well tuned for that. If you're using something like GHC.js, it's a little bit harder to do. And it also integrates with existing JavaScript packages. So if you have like your node package JSON, you can just throw in a bunch of regular JavaScript packages, and then your PureScript package can use those without too much trouble. And a more direct comparison between some of the existing ones, if you use Emscripten or UHC compiling to JavaScript, the output is going to be crazy, like several megabytes and pretty much impossible to understand. If you use, like I said, anything that preserves Haskell's semantics, then you're going to end up with something that enforces the lazy runtime. So again, your output size is going to be very large and there's going to be a lot of overhead to running it. And if you used JMacro, you're going to have Haskell involved in your build system, and maybe you don't want that. Maybe you only want Node.js involved. And Elm is actually only for the front end. They don't have any plans that I can tell right now to make it compile and work on Node.js. It's strictly for the browser, which is great because it's good at that. But if you want to use a language that is like that on the back end, you're kind of out of luck. So what does PureScript look like? If you've seen Haskell before, it's going to look very similar, in fact, almost identical. There's a couple strange differences that we'll get to later. But for the most part, you say, all right, I'm in this new module called main. I need to import exporting. This is how you control what's public and what's private. You're gonna drag in probably some more modules. So the prelude is like the core library. It's what everything has in common, more or less. And then you're gonna import a couple other things. Usually you're gonna import them qualified so that when you have lots of imports, you can tell where everything came from and they don't step on each other's toes. And then your main function has this type signature on it where we'll get to it later, but basically what it's saying is that you can print out to the console from your main and it doesn't return anything. And then this uses the do notation for some syntactic sugar. So if I wanted to put more like console logs in here, I could do that without any trouble. So yeah, it's about twice as long as the simple version, but it's still not too bad. And PureScript claims to have human readable output, and I think that's technically true, although it's not anything that somebody would have written by hand. So this is what our program looks like when you compile it. It goes and requires every module that you import, and then any functions you call on those modules get fully qualified, and you assign them to a variable, and then you export them. So it's pretty straightforward. This has a lot more typing than you might do for doing this in Node.js, but it's reasonable, and you can more or less follow along with it. So now that we know what it looks like, what do you get from PureScript? This is taken straight from the website. These are their high-level features that they get. I'm not going to run through these. Instead, the TLDR is that you get Haskell plus extensible records and effects minus some other stuff that Haskell gives you. And extensible records and effects are actually what I'm going to spend the bulk of this talk talking about because I think they're very neat, and this is like one of the core concepts in PureScript that it gives to the programming language world. So the first thing we're going to talk about is extensible records. This is known by a lot of different names: row polymorphism, structural typing, or static duck typing. And to me, this is the coolest thing about PureScript. This is the reason I started looking at it at all. And you can see an example of it here. Unlike Haskell, the dot does not mean function composition. It is what you would expect from any object-oriented language. It is like a property accessor. So this is saying, given a person value, take the person dot first and concat it with person dot last. So this looks exactly like how you would write it in a lot of more common, less esoteric languages. And you can call it by building up an object that has the fields that you need and passing it in. To do this type of thing in Haskell is really, really annoying. You have to get lenses involved. You have to say a type class that says, all right, I'm passing in something that has a first property and something that has a last property. It's not fun, and you can't do it with just the standard library. You have to pull in extra libraries. So another way you could have written this function is with pattern matching, which is another one of the features that PureScript has. You can pattern match on these variables. So you say, I'm accepting an object that has a first field, and I'm going to name that F, and a last field, I'll name that L. I think ES6 has a destructuring bind where you can just like say first, and it'll bind it to a variable called first. PureScript doesn't have that. They're considering it. So you can't be quite as pithy as you can be in ES6, but you can do this, which is powerful. So this is what the type signature for that function looks like, and it's a little verbose, but we're going to step through this. So what it means is that we're actually going to start in the middle here at the curly brackets. It says that I need something that has a first attribute that is a string and a last attribute that's a string. And then the or R at the end, or the pipe R, means it can also have anything else. So that means that you can pass in something that has like another field like age or birthplace, something like that, and it'll still type check even though it's technically a different thing. And then at the end it says we're returning a string. This thing on the right, the for all R, means that later in this type signature we have that R variable, and the for all R means that it should work for any R you can think of. In a language like Haskell, you don't have to do these explicit for alls. In PureScript, they are required. So at the beginning, you can see like all of the type variables that are going to be used in your type signature. But for the most part, you can just ignore the for all part and read the rest of the type signature. So I wanted to show what some of the error messages look like when you pass in values that aren't expected. So if you miss one of the fields, you're going to get this message that says, hey, I have an object that only has a first attribute, and I expected it to have both first and last. You get kind of some strange wording here about subsuming types, but all the pertinent information is there. Similarly, if you pass something with the wrong type, a field with the wrong type, then you'll get this where it says last was an integer and I expected it to be a string. Like I said before, you can add extra fields and that's perfectly fine. However, the type system does let you disallow this. So this one right here is the type signature we saw a couple slides ago. And then this one says that there's no for all R, there's no or R in the object. I expect an object that has exactly these two fields. So you can't just pass in a bunch of wildcard crap and have it work. And you can call that like this. If you pass in an extra param, it says, hey, this age param is in here, but it's not in the type that I was expecting. Typing out all those signatures can be really annoying and really hard to reason about. So if you see this type signature, you're saying, okay, well, it takes all these attributes and it spits out a string. It'd be a lot easier if you could say, oh, it takes a person record and spits out a string. So type aliases are the easiest way to do that. So this one has the extra, you can supply whatever other fields you want. This one does not. And then these are what the type signatures would look like. So to me, those are pretty easy to read. I think they're reasonable. So one of the problems with extensible records is that you may happen to have an object that has the right fields and they're the right type, but it's not the same as some other objects. So like, let's say you had a list that has a first and a last, and for whatever reason, they're both strings. It would type check, but it's not a person. So if you want to verify that your function takes only persons, you can wrap it up in this new type, which is more or less the same thing as the type alias we did before, but with an extra level of type guarantees. So this function will only take an actual person object that's been vetted by the type system, and it still works the same as before. You can do the destructuring, you can get at its fields and all that, but the type system is going to make sure that you don't accidentally pass in something that wasn't what you expected. So this is very similar to how Haskell handles this problem, where you define like a new data type that has specific fields on it, and that's the only thing that your function can accept. So I would say that like in general, this isn't going to be what you want to do, but if you have something with very common attribute names like X and Y, and you want to make sure that you don't accidentally pass in something that's not right, you can wrap it up in a new type and get it to work. And this is what the error would look like. This is saying, hey, you passed in just some arbitrary object and I was expecting an actual person. So that's all I got on extensible records. Does anyone have any questions about them? Again, this is like the coolest part of PureScript for me. I think it's a really novel way to avoid a lot of the boilerplate that you end up writing. Yeah, Josh.
I think you mentioned Haskell is getting this feature.
Yeah, so supposedly in the next version of Haskell, which is 8.0, they're going to get a similar language extension called overloaded record fields that allows you to define records more or less in this style and be able to get at their properties a lot easier. Unfortunately, it was supposed to be in the most recent release, 7.10, but it didn't make it. And it also behaves more or less like lenses. So, I mean, ultimately it'll be the same, but the machinery behind it is kind of weird. Had something else to say about it? Don't remember. Anyway, yeah. Next version of Haskell should have it. One of the things I like about having it in the core language and not as a language extension, and a very recent language extension at that, is that every library you interface with can take advantage of it. So, every Haskell library that's been written has had to work around this problem. And now there's like a new solution that will work for new libraries. But with PureScript, everything has it. So yeah, that's nice. And I feel like, PureScript had to, because coming from JavaScript where everything is more or less an object and can just have a bunch of attributes on it, you had to have something that could support this.
So why are they called extensible records? What is extensible about it?
That's a good question. I don't know, but my guess would be that it's this or R thing at the end. So you can say like, I have exactly these fields and then whatever other ones you want to put onto it. To me, that's the extensible part. I don't know if it means something else though. I'm sure there's a paper I could have read that would tell me. All right, we're going to move on to the next extensible thing, which is effects. We've actually already seen one of these. It was in the type signature at the beginning for the main function. So what this says is that F is what they use for effects. In Haskell, this is called IO. It just means like I can go out and do impure stuff in the real world. And then inside the parens here, you have some like an equivalent to the extensible records that we just looked at, but for effects. So this is saying I have an effect called console, and it has type console, which means that I can write out to the console in Node.js or the browser or wherever. This obviously looks really silly because it's console : console.console. This is because of the qualified imports for the console.console. But one thing I don't like about this is that these aren't uniquely determined by the type. So I can't change the name of this type variable right here. I can't call it something else like C or X or whatever. It has to be called console, and the type has to match. So I'm not sure why that's the case, that they have to be the same. It seems kind of silly to me, but maybe there's a good reason. So I'm not as enthused about extensible effects as I am about extensible records, because you end up with type signatures that look like this for your main function, where you're like, hey, I write out to the console, and I can generate random numbers, and I can throw exceptions, and I can access the DOM. Yes, it may be good to have very granular control over what your program can do, but at the top level, it quickly becomes cumbersome. So pretty much every PureScript program I've looked at doesn't have a type signature on its main function, because it doesn't really buy you anything. Like either you're going to run the main or you're not. The type signature is not going to give you a lot there. But for things that are lower in your stack, like if you have a random number generator and that's the only thing it can do, I can see how extensible effects is really useful, because you're not just saying this random number generator has IO type, it can do anything. You're saying this can only do random numbers. So the power to weight ratio is kind of weird. Like if you have one or two effects, I think it's nice. If you have more than that, I think it quickly ends up like Java's checked exceptions, where you're like, I just have to go through all this tedium to get this thing to work the way that I want to. Yeah, and again, you could do type aliases to kind of get out of some of this. And you can do the same thing. I guess I didn't put it in the slide here, but you can do the same thing with effects as you can with records, where you can say, I can do console and random or anything else. And that ends up being exactly like the IO type in Haskell, where you're saying, like, I can do whatever. But if you use something inside of a function, you have to list it in the effects list. And that's actually all the slides I have on effects. I know I spent a lot of time talking about records. Effects are basically the same thing, but for the effects system instead of records. Any questions about this? Yeah.
It seems like that would be useful if you wanted to have guarantees to determine. You immediately know whether this function is.
Well, it doesn't really give you that though, because you can write infinitely looping pure code. It doesn't touch the effect system. So determinism isn't really solved by this. There is an interesting language called Mort, which forces determinism as a totality checker, but that's a Haskell thing, so we won't get into that. But yeah, I mean, this is really useful, and I could see like if you wanted to write, a REPL that somebody can use on the web, you could guarantee that they're not using, the exceptions or the, I don't know, console, I guess, because you don't want them to write out to your console. I also assume, but haven't checked, that this could be useful if you want to like stub out the console part of it into some other thing. You could, say I implement the console effect and try to do all those actions. But again, I haven't done that. I don't know if it's actually possible. It just seems like a potential use. All right, so the next thing I want to cover is the foreign function interface. I'm not going to spend a lot of time on this because honestly, I haven't spent a lot of time on it myself, so I don't know like how to speak about it. In trying to learn PureScript, I focused on the PureScript side of things, not on the FFI side of things. But from what I understand and what I've read, if you define a function in PureScript, it'll just get added into your export for the JavaScript side. Since every function in PureScript is curried, you have to call it with these weird double parentheses. So you don't get to call it like a normal JavaScript function, but it is available and pretty easy to use. Going the other way, inside your PureScript file, you have to say that I am importing something from the outside world or from JavaScript, and you give the name and the type signature. From what I've seen in both this and when I was looking at Friga, which is like a Haskell for the JVM, specifying these types can be really annoying sometimes, and especially libraries that aren't thinking in a very typed way. Sometimes they can be impossible to represent. So you'd have to write like a JavaScript wrapper around a JavaScript library and then write a PureScript wrapper around your JavaScript library that gives it types, which obviously is super annoying. But it's not too bad. And then, so if you have this PureScript file, you have to have an associated JavaScript file with the same name, like in the same location. But instead of .PureScript, it's .js. And in there, you just have to export all of the things that you want to use in your PureScript file. And then this is how you would actually end up using it in PureScript. You just call it like a normal function, and it works, hopefully. So yeah, that's all I got for the FFI. TLDR, it works, but going from untyped to typed is always going to suck no matter what you do. So for this next section, I wanted to cover just some nits about the language that I had. And then after that, we're going to look at some real world usage so that you can sort of see what, not a large, but a modestly sized program looks like in PureScript. So one of the problems that I've encountered with PureScript and its ecosystem is that it's very, very granular. They have packages that export only one function. So like here, I'm importing AF, which is the asynchronous effect type, and then F for synchronous effects, and the F class, and the console thing for printing out to the console, and 3 different packages for loading up and printing out JSON. I got to bring in arrays, I got to bring in the either type, I got to bring in foldable type class, I got to bring in the foreign function interface, I got to bring in maybe types and unsafe maybe functions, I got to bring in nullable types, which are different than maybe types, and I got to bring in options and strings and string map and tuples, and it goes on and on. And this is for like a 20-line program. I mean, there's not a lot going on. So this quickly gets out of control. One of the benefits of it being so granular, though, is that it's very easy to make your own like core library that you can use. The problem with that is that the core library isn't going to be common among everybody that uses PureScript. So it's kind of a trade-off. Like by being very granular, you make it easy to get exactly what you need, but also that's a hindrance because exactly what you need isn't going to be what somebody else needs. So you're never going to have like common ground to work with. Another problem that has bothered me is that if you pull in some package, some PureScript package, and it depends on a bunch of other PureScript packages, those become available to your program, but you're not required to specify their dependencies. And this is something that I only really noticed because in Haskell, you can't do this. Like as soon as you want to use a transitive dependency, you have to put it into your package file and say, I'm using exactly this version of it. So like if I depend on PureScript arrays, it has an implicit dependency on PureScript tuples. So if then in my program I import data tuple, I'll be using whatever version PureScript arrays chose. So like let's say I upgrade PureScript arrays to 0.43 and they upgrade PureScript tuples to 0.50, which has some breaking change. My program's going to break, and hopefully I'll get a type error, but I never would have known. Like I didn't tell it to upgrade PureScript tuples, it just kind of happened. So this may be a problem with Bower. I'm not sure if it's just how it works. Haven't investigated enough, but it has frustrated me, and it's a little strange, I think. Oh, it does?
Yeah, so if your dependency you specify a range, and it won't install it for you, but you can install it, say, hey, I'm looking for this package, and it has to be compatible with this range. So you install it.
Sounds super useful. Unfortunately, for that, at least, it seems like the PureScript community has really rallied around Bower. Like every PureScript library is in Bower, only a handful of them are in NPM. So, I mean, it's certainly possible to switch back to NPM, but it seems like Bower has more or less won. So for me, as a somewhat proficient Haskeller, there are a couple strange differences from the Haskell syntax that drove me nuts while I was working on this. And these probably won't bug many people, especially if you haven't worked in Haskell before. It'll just be how it looks. But if you want to import a type, you have to follow with an empty set of parentheses. Otherwise, it'll think you're importing a type class, and it'll fail. If you have this where clause in Haskell, you are allowed to indent this more. So you say like blah, 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 where, indent, all this other stuff. In PureScript, it has to be at the exact same level, which to me looks strange, but to other people probably looks fine. With functions, you're allowed to define your own operators, so you can do whatever you want. But you can't define them in the infix form, so you can't say x bang y equals whatever. You have to say bang xy equals whatever. It's just a strange problem. Like I mentioned before, you always have to explicitly qualify your type variables, so you have to do for all over the place. For type class declarations, the arrow goes the other way. So in Haskell, this would say ord a arrow ek, I think. And then instances have to have names, and this is so that they can be exported to JavaScript. And they always end up looking, there's actually a typo in this, there should be a space between arbitrary and unit on the right side of the colons. But they always end up looking like type class name and then class name, or data type name. So they're pretty, I don't know why they can't be done automatically. One thing that I really like, actually, that's different from Haskell is that do statements start a new layout block, and you don't have to put a $ in front of them for function application, which ends up reducing the need for $ a lot, which is one problem that I have with Haskell, because they're really annoying to read. And they have a little bit more verbose type names for some of the core types. Instead of like bracket or square brackets around the A, it's list A, and instead of an empty set of parentheses, it's unit. I actually like this better because I think it's a lot clearer what's going on, but I could see that it would drive some people nuts. And the error messages aren't always great. So for instance, if you try to define what looks like a very simple function that should work, since it doesn't have an explicit type signature, it tries to make it as general as possible, and then it blows up because it doesn't like the type signature that it made for it. And it says, hey, I don't have an instance for semiring for _5, which obviously means that the variable x doesn't implement the semiring interface or type class. One of the things I actually really like about these error messages is that they include a link to a wiki page for more information about the error. So if you get this error and you get really frustrated, you can go to the wiki and say, hey, I got it, doing this, and this is how I fixed it. And not all of the error messages have wiki pages yet, but if there's not one, you'll get the create a wiki page. So I feel like this is a good way to sort of collect community knowledge about errors and how they happen and how to fix them. And my last nit is that they didn't use pipe forward and pipe backward from Elm. They used $ and £, for function application and reverse function application. And this is especially annoying because £, is not even the same one that Haskell uses. It uses ampersand, so it's weird and different than where it came from. Those are all the nits I have. I'm going to transition now into a real world example, or sort of real world. I think calling it real world is probably optimistic. So PureScript, like I said, is available for Node.js or the browser. Looks terrible. And since it's a pure functional language, it's kind of obvious that you might use it with a sort of FRP type library like React. I tried to get PureScript working with React and unfortunately was unable to because the PureScript React package exports the same name as the React package, but with a capitalization difference. So React is like lowercase r and the PureScript one is uppercase R, and I couldn't get it all figured out. So instead I went with this PureScript library called Halogen, which is their equivalent. It uses the virtual DOM npm package behind the scenes, and it provides a React-like layer on top of on top of PureScript. So I guess I can run this as well. Okay, so this, you can't see the whole thing. This is what it does. It's a toggle button that goes on and off. That's it. We can see here the JavaScript that it generates. This is with source maps, so you can kind of poke through the whole thing and see what it looks like. These are all the packages that it brought in. Like I said, very, very granular. The main function is the interesting one that I actually wrote. And again, it's not something that a human would have written, but you can sort of read it and understand what's going on. But let's look at the PureScript because it's easier to read. So I have to pull in the asynchronous effect and the halogen library. And the halogen library itself is split up into a bunch of smaller components. And then I launched this asynchronous thing, and what this does is it says, all right, do all your asynchronous stuff. If anything goes wrong, throw a synchronous exception and blow up. So it's kind of an unsafe way to do these things, but good for demos. Here's the destructuring assignment. Like I said, in ES6, this would be a lot nicer. You could just say that. And then you tell Halogen to run your UI with your initial state, and then you tack it on to the actual HTML body, and then you're good to go. So the way that Halogen works is that you have your UI, which is a component, and it takes your state, which starts off with your initial state, and a query, which I think is kind of poorly named, but basically it's like the actions you can take on your state. So for instance, this thing is just a button that you can toggle on and off. So my only query action is to toggle the thing. Similarly, my state is a object, so this is a record, an extensible record, and the only thing it tracks is whether it's on or off, and by default, or initially, it's off. So your UI is just a component that renders your state and then evaluates queries. So like when I click the button in the web, that sends a query to Halogen, and then Halogen my script evaluates that, and then Halogen re-renders the thing with the new state. So inside this render function, the type system forbids me from updating the state. So that's one thing that you can do in React is you actually could update your state in your render function. You're definitely not supposed to, but you can. In Halogen, the type system prevents you from doing that. So this is how I would render a very simple thing. Everything has to be wrapped up in a top-level container, just like in React. And then inside this div, I have a header with text in it that is the name of this project, and then I have a button with an on-click action that sends this toggle query, and then it also has text inside of it that checks the state, and if it's on, then on, else off. So I know the syntax is a little strange. It's not quite as nice as JSX, right? Isn't that what it's called? Yeah, so it's a little wonky, but to me, as a Haskeller, it reads pretty normal. This is how I would write a lot of Haskell stuff. But yeah, so these things are provided by Halogen, the e.onclick and the e.input. And then this is the thing that actually is responsible for dealing with user input and changing my state. This is a destructuring assignment. So for instance, if I had another state change, like if I had one that just always turned it off, oops. It could be like that, and then I would do a bunch of other stuff. Or if I had one that also turned it on, I could do this. And the benefit of writing an eval function like this is that as you add more things up here, you'll get a compile error if your eval doesn't cover all the cases. So it'll say like, hey, you forgot to implement the on eval. So yeah. But for toggling, all I do is modify the state. So this takes a lambda that is given the state, and I return it with the state inverted. Pretty straightforward. This also could be written a variety of different ways. One of the problems with the extensible record syntax is that you can't do like, what you may want to do here would be halogen.modify state state.on equals not state.on. You cannot write this because state.on is like a property access or reader. It's not a writer as well. So this would, evaluate to, false or whatever, and then it tried to say false equals whatever, which obviously doesn't make sense. So to get this type of thing working, you do actually have to bring lenses into the mix, and there's a lens library for PureScript, so you can do it. I assume it would look something like probably % equal. I'm not sure. Probably just be this actually. So lenses are still necessary to do updates and assignments, but just reading the things out is really easy to do. Also, you could have written this if you wanted to use the wonky variable or function application. You could do it like that. Doesn't matter. Since Casey asked earlier, the backslash is the start of a lambda. So like in ES6, this would be state is equal to, state.on equals not. Something like that. I guess you need curly brackets too. So yeah, that updates your state, and then the thing that gets passed into this eval function, or that is the parameter to your query, is like a callback. So the thing you do at the end is return the callback. There's actually, could have done return. There's synonyms in PureScript. I went with pure because it's called PureScript, so haha. And yeah, that's it. This is probably the simplest React component or React style component you could write. I don't know how it compares to writing a similar thing in React. I guess I should have done that and had a side-by-side comparison going here, but I feel like they're a similar amount of weight. Any questions about this or comments? Casey, how do you feel about it?
It's pretty strange.
Because of the syntax or the semantics or both?
I think changing the value of state there is very strange. Like you said.
You mean the way that it's updated is weird, or just the fact that you have to update it?
That's how you update it.
Yeah, it is pretty weird.
I imagine this would be very, very verbose on our larger React components.
Yeah, and actually that's one of the things I'm not clear about. Like, obviously in an app of our size, you're going to have, thousands of actions you can take. So I don't know if your top level component has to be aware of all of them, or if you can keep them contained in the smaller ones. Yeah.
That's actually what I was going to ask. How does it do dependency tracking? Does it re-render the entire DOM and then virtual DOM and then dip it, or is there a way to direct render stuff?
From what I know, or from what I understand, I think it just leans on the virtual DOM library, and so every time the render gets called, it spits out a new virtual DOM and diffs them, and then does whatever update is necessary. But the virtual DOM library is pretty good. I don't know. I don't think it's what React leans on, but some other FRP JavaScript library uses it. It works pretty well. Yeah, I wish I had like a larger example to show, but it's hard to come up with like a contrived example for a little like simple but not too complex app to go. Anyway, they do have a couple examples in the repository if y'all are interested in checking it out. It's just PureScript halogen. Googling for it should find it. I don't know why it's called halogen, side note. The React one is called thermite, so may have something to do with that. I don't know. All right, so back to something. There we go. And that's actually all I got. So Does anyone have any other questions, or is there something that I didn't cover that you would like to hear about PureScript? So the company that made Halogen is called Slam Data, and they do use PureScript. I'm not sure how much, but we can see on I don't actually know what they do. I've never looked at their site. Analytics for NoSQL. Anyway, they use it. PureScript. I don't think they list like companies that use it. They do have some projects, but these are like personal things. So Slam Data's on here. There's a Mu Canron implementation in PureScript, which I know Josh will like. Yeah, I mean, I don't think it's widely used. It's not at version 1.0 yet, so I don't think even the people that made it would be widely using it. I was reading an interview by the creator of this language, and he was talking about how his sort of design goal for it is not that you would write your entire application in PureScript, it's that you would write particular important components in PureScript, which is why I guess he feels that the FFI is very well designed, and so that it allows you to write like a mostly JavaScript program with some PureScript components. Yeah, Josh?
So what are the compile times like? Does the compiler have any way of doing code elimination or anything like that? I guess you don't need it because you have to explicitly require every single tiny thing that you need. So essentially you're doing the dead code elimination.
Yeah, so let me pull up a project of mine. So I have this project called PureScript Batteries that pulls in like 50 of the most commonly used libraries. So if we blow away all of the Bower components and the node modules, take a second there, and PSCI. Okay, so for the actual node package part of this, it's just PureScript and Pulp, and Pulp is their like build tool, and it shells out to Bower and does some other things for you. So when I do an npm install, it's also going to go fetch all of my Bower components and install them. It won't compile them, but it'll like get all their sources and put them where they belong. So I have this set up to print out how long a thing took after I run it. Installing PureScript itself takes, I'd say, maybe 30 seconds, but typically something you'll only do once for a given project. So while we let this go, I haven't noticed the compile times be a problem. I haven't written a very large program, so I don't know if it gets worse. But in my experience, it's been pretty snappy. Like, it's definitely not a pain point. And also, there's a new version 0.7.5 of the PureScript compiler coming out, and it apparently has a lot better compile times. So it may even be less of a problem in the near future. And as for dead code elimination, it does do that by default. So it'll only output the stuff that you actually end up using. And like you said, the very granular imports definitely help with that. But I think it will see like what you actually end up calling from those things. I'm not sure how advanced its dead code elimination is. So that was done. It took 49 seconds to both install PureScript and the PureScript build tool and download all of these PureScript packages. There's a ton of them. So if we're actually compiling it, we can do an npm run pulp build. So what this is going to do is build my project. My project pulls in all of these other projects. So this will effectively compile all of them. And I don't know how long this will take, but I'm guessing like, yeah, okay, less than 10 seconds. 7 seconds to compile a lot of packages. So if we look at bower.json, we can see that these are all the packages that it pulls in. I think there's like 49 or 50 of them. They're all pretty small, granted, but compiling all of these things in 7 seconds, I think, is pretty quick. Yeah, so pulp, oh god. Pulp has a watch option. So yeah, you can run it in the background and just say watch. I don't think it does like incremental builds. I guess we could see if we try to run another build, how quick it is. 2 seconds, so maybe it does. I don't know. Like I said, it hasn't been a problem for me. Doing the watch files is fast enough. Any other questions or comments? All right, well, thanks for listening. Let me kill the Hangout here.